In this video, we're going to take a look at multiplying polynomials, and we're going to start doing that by multiplying the simplest of polynomials. We have two monomials that were being multiplied here. So we have negative 5x squared times 6xy. And in order to multiply monomials, all we do is we multiply the integer parts together, and then we'll multiply the variable parts together, like so. Now, negative 5 times 6, that's pretty easy. It's a negative number times a positive number gives me a negative 5 times 6 is 30. And one way that we can look at x squared times x is we have x squared is x times x, and then we have this other x here. So x times x times x, well, that's x to the third power. And y isn't being multiplied by anybody, so we're just going to go ahead and leave y alone. So negative 5x squared times 6xy is negative 30x cubed y. Let's take a look at the next one. This is 2a squared b times c squared times negative 3a b to the fifth c to the fourth power. Well, first we'll do, like I said, the integer parts together. So 2 times a negative 3 gives me a negative 6. Now, if you noticed up here, when I multiplied my x squared times my x, all I really did was, well, I expanded it out, and I noticed that if I'm multiplying x by itself twice and then once more, then I'm multiplying x by itself 3 times. So x times x times x. So really, if we take a look at our exponents here, I had x to the second power, and this is x to the first power. Because remember, we assume there's a 1 there because x to the 0 power would be 1, and that's not what we have. But if you notice that my result was x cubed, and 3, the third power here on x, is simply 2 plus 1. So we can also look at this a squared times a as a squared times a to the first power, and that'll give us a to the third power. Well, what happens when I have b times b to the fifth? Well, I have 1b there, and 5 times b 5 times itself, b times itself 5 times here, so that'll give me b to the sixth power. C squared times c to the fourth, 2 plus 4 is c to the sixth power also. So negative 6a cubed b to the sixth power, c to the sixth power is our result there. So that's multiplying monomials. We use our one of our exponent rules here, our product rule for exponents, that when we have the same base, and a different exponent, all we will do is keep the base and add the exponents. That's the rule we applied to get to the x cubed there, and to get to the a cubed, b to the sixth, c to the sixth there. Let's take a look at what it means to multiply a monomial to a binomial. And here what we're going to use is we're going to use distribution. We're going to distribute the factors. This 2xy is going to be multiplied first by the 2x, and then we're going to multiply it to the negative 3y. Using the same rules, 2 times 2 is 4, x times x is x squared, and we have a y times no y's there, so we'll just leave it as 1y there. Now a 2 times a negative 3 is a negative 6. X times no x is there is just the 1x here. Y times y is y squared. And we're as simple as we can get here. That is fully distributed. Remember, distribution that means multiplication across addition or subtraction in this case. But that's distribution. So let's take a look at the last one here. Now we have two binomials that we're going to use. Again, we're going to use distribution. And I always want to think of this as distribution, although some of you may remember from high school, your teacher saying FOIL, where you do first, the outer, then you do the inner, and the last. I also call it the crab claw. But it's really only specific to when you're doing a binomial times a binomial. Sometimes you'll have a binomial times a trinomial, or a monomial times a four-termed polynomial. So it's really not good to get locked down into these fun little acronym definitions, and just make sure you understand that what you're actually doing is distributing. First, I have to distribute the 2a to the 4a and the negative b, and then the negative 3b to the 4a and the negative b also. So let's start with that. 2a times 4a is 8a squared. 2a times negative b is a minus 2ab. Negative 3b times a negative 4, times a positive 4a gives me a negative 12. A and b, so I'll leave the a and b, I'll put them in order. And then I have minus 3b times a negative b, so that's negative times a negative is a positive, and 3b times negative b is a 3b squared. And notice that I have in the middle I have like terms here, a negative 2ab and a negative 12ab. So what do we do with like terms? Well, with like terms we have to combine them. So 8a squared. If I owe $2 and I borrow 12 more dollars, I now owe 14 of those AB dollars, and then plus 3b squared. Let's take a look at a couple more multiplying binomials. And this one is an interesting one. I want to use a different tool here. The tool I want to use is called an area model. So I'll have an a plus 2b up here. And I'm going to put that into a box. So this a plus 2b is this a plus 2b here. And in another color, I'm going to do this a plus 2b. Notice that they're the same. A and a positive 2b here. They're the same number, right? My two factors are the same number. So in this first box, I'm going to multiply the a times the a, and I get a squared. And in the second box, I'm going to multiply this a times the positive 2b, and that'll be a positive 2ab. And what's going to happen is my corners here, going up this direction, will be my potential like terms if I have any. So let's see how that fares itself out. I have a positive 2b here multiplied by an a. Well, that's also a positive 2ab. And then 2b times 2b is a 4b squared. And lo and behold, I do have like terms in these corners. So my final result is a squared plus 2ab plus 2ab is plus 4ab. And my final term is this positive 4b squared. This polynomial is called a perfect square trinomial. What that means is a perfect square trinomial takes the form a squared plus 2ab plus b squared, meaning the first term is a perfect square, the last term is a perfect square, and the middle term is 2 times the square roots of a times b. So here the square roots of a times b is 2ab, and I have 2 of them. That's why I have 4ab in the middle. The square root of a squared is a, so that's what this term is here, this a. That when those two a's multiply, I'll get a perfect square. When these two b's multiply, I'll get a perfect square. And if I just took this and multiplied it, 2ab, and then doubled it, it becomes my middle term. You're going to learn to recognize those over time. But let's do one more, which looks like it. I have the same terms like in the previous problem. I have the same terms. I have a y and a y, and a 4 and a 4. But notice now I have a plus here. This is plus 4, and the other is a minus 4. So it's y plus 4 times y minus 4. And let's use that same trick. Let's use that same box here so you can see what happens to my like terms. So this one is, the first term is y plus 4, and the second term is a y minus 4. Well, when I multiply my y's, I will get y squared. When I multiply my y plus 4 times a positive 4, I'll get a positive 4y. When I multiply this y times this negative 4, I will get a negative 4y. And then this 4 times this 4 is 16, but a positive times a negative is a negative. And look what happens to my like terms. I have a negative 4y and a positive 4y. So if I have 4 of something and then I take 4 of them away, or contrariwise, if you owe me $4 and you pay me $4, then really you owe me nothing, and the only thing we're left with is the y squared minus the 16. And again, this is another special one that you should recognize. This is the difference of squares, where my first term is squared, my second term is squared with a negative or a minus sign in the middle. That means if I have x squared minus y squared, what that means is my factors are x plus y times, you guessed it, x minus y.